All right, so on 3.1, let's go through here. Which average, that's kind of the middle value, or which average, central tendency, represents the middle value of a data distribution? I don't know if I like the wording there, but which one represents the middle of the distribution? The mode, the median, or the mean? The median. The median is the middle of the distribution, okay? Which one represents the most frequent value in a distribution? Happens the most? Mode. And which one average takes all the specific values into account? Mean. So what that means is you add them all up and then you divide by that. So it takes all values into account. And so that includes maybe your big outliers or that might make the data a little skewed. Find the mean, median, and mode of the data set. So on this one, you've got a few options here. You could do this. You could do this kind of by hand, or you could do this in the calculator. You could do this by hand. It's a pretty simple data set. So I could go to first the mean. I could add them up, divide by 5. So I'll add up these values. 9 plus 6 plus 8 plus 6 plus 7 and divide by 5. I get 7.2. So we're probably going to have different numbers here. So keep that in mind. Median, I'll put them in order. So let's put these in order here. So I've got 6, 6, 7, 8, 9. So which one's median's my middle one? I've got an odd number of numbers. So my middle is going to be 1 in the middle. So my median's going to be 7. And then my modes, which one's most occurring? So which one happens the most? 6. You could also use this using the calculator. Okay, I could show you that real quick. 6, I could enter these in the calculator, stat, edit, press clear, press down. So I go to 6, 6, 7, 8, 9. So I enter the numbers, stat, enter to do that. And I press stat, calc, 1 var stats. And so 7.2 is my mean, median 7. The mode they don't give you, but you could just spot that. It's got to be 6, okay? Number 3, when a distribution is mound-shaped and symmetrical, what's the general relationship between the mean, median, and the mode? Okay, this is a good question because this was not covered very well in the notes. Okay, so when it's a mound-shaped and symmetrical, how does the mean, median, and mode compare? So mound-shaped and symmetrical looks like this, okay? So mound-shaped and symmetrical looks like this. So when it's mound-shaped and symmetrical, here's the thing, and I don't know if I put this in the notes, so if I didn't, I apologize. When it's mound-shaped and symmetrical, that means the mean and median are about the same. Okay, mound-shaped, symmetrical. Mound-shaped because it's got a peak in the middle, and then symmetrical because they're symmetric on both sides, that you fold it in half and be about the same. Now, where would the highest occurring the mode be at here? If you were to take a guess, where's the highest occurring value at? Where would that occur at? Left, middle, or right? Where's the highest occurring would be? Where do you think it would be? Which one's got the highest point? It's the right there. So the mean and median and mode would be about the same. Because when a symmetric one, the mean and median are about the same, okay? And then the mode, the highest occurring is where the peak would be in that distribution, and so it's in the same. So it'd be approximately equal. Okay, and we've talked about there's shapes of distributions. If it's skewed left, the mean is less than the median. If it's skewed right, the mean is greater than the median. I did not cover that. All right, now you're going to be introduced to your BFF salt. Okay, salt, you're going to love salt. Okay, so let's go to number 4. So compare the mode, mean, and median for this distribution. So I'm going to click use salt. Okay, so click use salt. And I might do this in a separate, well, it's going to continue doing, I'll do this in a separate window. And then once I click use salt, I'm going to go to descriptive statistics. Okay, and look at this. It spits it out for you. So I click on descriptive statistics throughout the year. We could use charts and graphs kind of from chapter 2. We'll use distribution calculators. We'll use sampling. We'll use inferential statistics later on. But for now, mean is 4.6. Mean is 4.6. I apologize. The median, let's see, the median here. I don't know if this tell you the mode here. The median is 3 for me. And then the modes, which one's most occurring? So which one happens the most? I have 2 2s, so my mode would be 2. So there's my mean, median, and mode. Okay. add 7 to each of the data values. So what I do there is I can go back. I could do this a variety of ways. I could go back. Let's say we want to use salt. I'll go back to the data set. I can click on this icon here, the edit icon. Now, your might be different. I'm going to add 7 to each one. So I started with 2. I'm going to add 7. Whoops. So it'll be 9. So 2. So I'm going to add 7 to it. So I'm adding 7 to each of the data values. Okay. So add 7 here. Add 7 here. And then add 7 here. Okay. All right, so we just added 7 to each of the data sets, and it should automatically update. So you see the mean is now 11.6. This is kind of a discovery thing. We talk about this a lot at AP Statistics. We talk about this a lot. The median is 10. You will use standard deviation tomorrow, tomorrow, and then you'll use a lot of this other stuff. Mode, which one occurs the most? It should be 9, because if I go back to the value, the data set, it's just the one most occurring should be 9. So let's talk about the impact. What we did was this is called adding a constant to the distribution. We add a constant. We add the value of 7. So we add a constant to the distribution. So adding a constant to the distribution, what did that do to the mode, median, and mean? What did it do to it? It increased it by C units. So what does that mean? Adding the same constant C. So if I added 7, adding 7 to each of the data sets results in the mode, median, and mean increasing by 7 units. Okay. So that's a kind of a property of measures of center. If you add a certain amount to the measures of center, it'll be the same. So like from going forward, if you wanted, you could just, if they ever ask that question again, you could just add the constant to those and you'd be right for measures of central tendency. Okay. It does not always hold for measures of spread. We got to talk about that later because that's different. All right. This will be like the one on your test. Okay. So your one on your test will be like number 5. How high is in the Death Valley? They've got the ground temperatures. Compute the mean, median, and mode. So I'm going to go click on use salt. Okay. Said you're going to love salt. Okay. You're going to love this thing. So it transfers over. I'm going to click descriptive statistics. You could also copy it over. So I can do Control C and Control V. I can just copy it over. Okay. Now be careful, decimal places. It said 4. So, well, I can't go 4 on that. So you just leave it alone. So I can do select it, Control C. So all you're doing is just copying the answers over. Okay. So it's doing the work for you. In the real world, you're going to have an Excel document or something do the work for you. So you're not going to worry about doing this by hand. It'd be inefficient to do it by hand. You got better things to do. Now for mode, what I would do is I would go on the data set, go back to data set, and I would go click on the data set, click on the temperature once, and it would order the data. And ordering the data will allow me to see which one happens the most. I got 150 twice, 167 twice, 182 3 times, 184 twice. And so I got 182 is going to be my winner there because it happens 3 times. So this allows me to order the data. That's another nice thing about the salt. And that allows me to see what it's like in order. So 182. Okay. All right. So now weighted mean, this one will be on your test. So you got to be careful here. In your biology class, your final grade's based on several things: a lab score, scores on 2 major tests, and the scores on your final exam. There's 100 points available for each score. However, the lab score is worth 19% of your grade. Each major test is worth 24.5%. Each final exam is worth 32%. Compute the weighted average for the scores: 96 on the lab, 65 on the first test, 86 on the second major test, and 88 on the final exam. Okay. We got a mouthful here. So this is called a weighted average. And so what it does is it weights everything appropriately. If you're calculating grades for a class, for high school or college, you've probably used a weighted average to do that. Okay, so let's look at the different things we have. We have a lab. So we have the lab score. And so what you're going to do is you're going to take I'm putting the lab right there. You're going to take the percent as a proportion. So 19%, you're going to convert that to a proportion. So 0.19. And you're going to multiply this by your lab score. So my lab score was a 96. All right, let me rewrite this. So the 96 is your lab score. You got lab score, and then this is the weight, lab weight. What I mean by that is that's how much it's weighted. Plus, now we're going to add to it the other components. Okay, there's each major test is worth 24.5%. So your next test is 24.5%, so 0.245 times your first test score. So 65 on the first major test. So that's the test weight. And that's their first test. Plus the next weight, or plus the next one, we had another major test. So another major test is going to have the same test weight. So your same test weight, because it's 24.5%. Yours will probably be different. Times your second test score, so 65. And this is one of those things, you don't have to write this down. If you're like, this is something you could type in your calculator. I'm writing it down for teaching purposes. Okay. I'm not doing a great job there showing that. And then 88 on final exam. The final exams were 32%, odd percentages. So 32%, that's final exam weight. And then the 88 on that. So now we're going to use this right here. I'm going to kind of come back to this. We're going to use this right here to calculate our weight. So it's the weight for each one times the score plus the weight for each one times the score. It's not that bad. You just got to see how it's set up first. So 0.19 times 96. Sometimes the percentages get the best of you. 0.245 times 65 plus 0.245 times 86 plus 0.32 times 88. And so we got 83.395. What do they want? I'm not sure what they want for decimals here. I think they want the whole thing. Okay, so I don't know if they want you to round there.
I think that they wanted the whole thing.
And if they don't, I get this wrong, then it's on me. But I think from last year, they wanted the whole thing. Hopefully you don't have anything bizarre in there. Okay, so I was trying to remember from last year. They don't have anything bizarre, but it's just the weight times the weight is a decimal times the value plus the weight is a decimal times the value. Okay, so on this one, we're going to explore the multiplication, the multiplying data sets. We're going to do some exploration. I like how this is set up. So we'll click use salt first. So we'll click use salt and we'll go to descriptive statistics once it loads. And so we could copy this over here, Control C, Control V. Is that the mean there? Be careful about the order there. I almost messed that up. And then the median, I'll just put 7. Okay. Whatever you get to the activities for 3.2, you're going to probably want to copy it more because those are going to be nastier values. Like these are pretty nice here because it's a small data set and it's nice values. Which one happens the most? We got 6 there. Okay. I'm going to have you guess. What do you think is going to happen to your mode, median, and mean when you multiply each data set value by 6? What do you think is going to happen to these values? You're right. So what you'll do is you could go, I'm multiplying by 6, so be careful. So I'm going to multiply. I'm going to go back to data set and multiply by 6 here. So 36. 36. 6 times 7, 42. 6, 60. And 14 times 6. That would be 84. Yep. Check. So it'll automatically update. Let's see if our guess was right. We have a median of 42 and a mean of 51.6. So 51.6. I'll come back to that screen here in a moment. And then a median of 42. Whoops, 42. And then the mode, which one happens the most? Let's go back to the data set, 36. So what happened here? It's what you would have guessed. If you multiply these values by 6, you would have got the new set of values because each of these multiplied by 6 gives you these. So how do you think the mode, median, and mean will compare when you multiply by the same constant? Okay, so it's going to increase by a factor of C. Okay, now we've got a little bit of an interesting situation here. To convert the mode is 66 inches, the median is 72, and the mean is 67. So we're giving us new information here, given new information. And to convert the data set to centimeters, we're going to multiply each value by 2.54. So how would I find the mode, median, and mean of the new distribution in centimeters? If I've got the original distribution, I want to convert it to inches to centimeters. And to convert to inches to centimeters, multiply by 2.54. So what will I do with these three values? Multiply by 2.54. So I'm going to take my mode 66. So that's what we proved. You multiply by a constant, it's just going to be multiplied by a constant like 2.54. My new values will be increased by a factor of that. So it'd be 167.64. The median, 72 times 2.54, 182.88. Whoops. And then my mean would be 67 times 2.54, 170.18. All right. So pretty simple. Those are called, that's another little basic rule of statistics there. Okay. All right. We got, I missed one. What did I miss? I did not mean to do that. I apologize to the people watching. That must have happened by accident without me. I clicked this one. That must have happened without me knowing there. That's what I get. I promise I selected that one first. So, okay. I'm afraid I missed some of these other ones, though. Having salt helps you. So on this last one, we're going to look at some of the things we talked about earlier. How expensive is Maui? They got the cost for random sample of condominiums, and I believe there's 20 in this data set. So we're going to compute the mean, median, and mode for the data set. So we'll click use salt. We'll click use salt here. The mean, median, and mode for the data set. So I can go to descriptive statistics. Okay, descriptive statistics. The mean is 134. The median is, let's scroll over. The median is 66.5. And then the mode, I'm gonna put them in order first. The mode, I'm gonna click on the data set here because I'm gonna need to do this anyways. I'm gonna go back to the data set. I'm gonna click on these here. So I'm gonna click on this. So I'm gonna put them in order. All right, so we're gonna talk. We talked about this in our notes, but mode. I'm sorry, I didn't do the mode yet. I was skipping ahead to trimmed mean. So let's see which one happens the most. I have 360s, so it's going to be the 360 there because those are the most occurring. A 5% trim mean. Now we had one exactly like this in our notes. So it's pretty simple. It's pretty nice because in our notes in a trim mean, you take 5% trim mean, you trim 5% off the bottom and the top. So you want to first take 5% of the number in your data set, which is the same as we had in our notes. 5% of 20 was 1. Okay, 5% 0.05 times 20 is 1. So that means we need to delete the bottom point in our data set and the top point in our data set. This is not that bad. We'll use salt for this. So I'll go back to my descriptive statistics here, and I'm going to delete the lowest value and the highest value. Okay, and so that will trim the mean. And so what this, I didn't mean for it to reset like that. Did I? Okay, I didn't mean for it to click that like that. And I'm going to delete the highest one. Okay, and so now we're going to do a new mean. And our new mean, so this is where you want to use the copy thing. Control C, because that's a repeating decimal. Control V. They had 4 decimal places on the last one. They have 4 here. 2 decimal places. Of course, they changed it. Oh yeah, dollars and cents makes sense. So it'd be 0.89. So the question is the trim mean more accurate? So if it's more accurate, you want to compare it to the other measures of central tendency. That sounds like a mouthful. What is that? The mean, median, and the mode are the measures of central tendency. You want this value here. You want these three to kind of, ideally, you want these three to kind of align together, be close together if they can. And so we're going to ask ourselves, is the new mean closer to the median and mode than the old mean? Yes. So this trim mean is actually probably a better estimate than the old mean. Okay. And the reason why we talk about this, there's a big high outlier, or it appears like an outlier on there. So we have an outlier is making the mean go higher than it should. If you're a travel agent asking about the cost of a condominium, so if you're a travel agent and you're trying to sell condominiums, you're trying to basically, say, hey, what do you expect to pay? What would the travel agent want to sell? Would they want to sell if you're trying to sell it, would you want to sell it advertising a price of around 118 or 134? Or would you want to do it around the price of 66.5? So what would you try to do as a travel agent? Which one would you want to do? I would want to do that. And the median's more accurate. And so the reason why is because this distribution is skewed to the right. What does that mean? That means there are a few high outliers on the right side that are making the mean go up higher than it normally should be, higher than your kind of typical measure of central tendency. So that's why it's skewed to the right. Is there any other information that might be useful, such as the spread of cost? This kind of leads into the next lesson. So some things that might be useful. I would say if you're talking about spread, then we got to say which one of these are covering spread. Which one of these are talking about spread? So which one of these answers are talking about spread, the lowest and the highest? Because you're talking about the lowest and the highest, you're talking about how spread out the distributions are. You're trying to see the range of values. So that is why that one would be the best answer for that, because it references spread specifically.